What is showing up on your screen right now is a cut and polished diamond, ready to be sold for a few $1,000s. It is a beautiful stone, isn't it? But here is something that might surprise you. This very same stone looked nothing like this when it was first found out in nature. Honestly, it probably did not even draw much attention, even though it was a real diamond and even though it had a shine that was clearly different from all the ordinary little stones lying around it. But do you know where this diamond actually came from? Well, this particular one was found in a river by an ordinary person, just like you and me. The only difference is that this person already knew there was a real chance of finding diamonds in that region, and they went after it. And now here is the question I want to put to you. If I handed you the exact same knowledge that this person had, do you think you could find diamonds in your own region too? Maybe you think you couldn't, but this is completely possible as long as your area has at least some record of ancient volcanic activity, which, surprising as it sounds, tends to be pretty common in the very places where diamonds turn up. And that is exactly what you are going to discover in today's video. How diamonds that stayed hidden inside volcanic rock for millions of years ended up lost at the bottom of rivers, and more importantly, how you can learn to find these stones with your own two hands, without expensive machines and without any professional mining equipment. To understand how a diamond ends up sitting at the bottom of a river where a regular person can reach it, you first have to understand where it really comes from. And the answer is a lot deeper and a lot older than almost anyone imagines. A diamond, at its core, is just carbon. It is the very same element that makes up the graphite in your pencil and the charcoal in your backyard grill. The thing that turns plain, cheap carbon into the hardest, most valuable crystal on the planet is the conditions it was put together under. To build a diamond, you need a combination of pressure and heat so extreme that it simply does not exist anywhere near the surface. It only exists deep down inside the earth, roughly 90 to 125 miles below your feet, in a layer geologists call the mantle. Down there, the temperature climbs well past 1,800 degrees Fahrenheit, and the pressure is tens of thousands of times stronger than the air that is pressing on your skin right now. Under those brutal conditions, over millions and sometimes billions of years, the carbon atoms lock together into the tightest possible arrangement found anywhere in nature. That arrangement is what we call a diamond. So here is the first thing that tends to surprise people. Every natural diamond you have ever laid eyes on is older than almost anything else you could ever hold in your hand. A lot of them finished forming before the first dinosaurs ever walked the earth. They were already complete, already perfect, sitting quietly about 100 miles underground, long before there was anyone around to ever want them. In a real sense, a diamond is a little messenger from the deep past, carrying a piece of the planet that no human will ever visit. But a diamond that stays 100 miles down is completely useless to you and me. For it to matter to anybody, it has to come up. And that brings us to the real hero of this whole story, a special kind of rock with a name worth remembering called kimberlite. Kimberlite is the rock that carries diamonds from the deep mantle all the way up to the surface, and it does it in one of the most violent events this planet is even capable of. Picture a narrow column of molten rock loaded with gas and water, suddenly finding a crack and racing upward from those incredible depths. We are not talking about a slow, lazy lava flow like the ones you might picture in Hawaii. Geologists estimate that this kind of eruption can travel upward at speeds that may reach the better part of 100 miles an hour, blasting toward the surface almost like a bullet fired straight up out of the planet. As that column rises, it rips loose chunks of whatever rock it passes through, and sometimes, by pure chance, it grabs diamonds along the way and drags them up to the surface with it. When that column finally breaks through and erupts, it leaves behind a structure shaped almost exactly like a carrot stuck in the ground, wide at the top and narrowing as it goes down. Geologists call this a kimberlite pipe. So if you ever hear prospectors talking about hunting for a pipe, this is what they mean. It is the frozen throat of an ancient volcano packed full of the rock that brought the diamonds up from below. Now, here is a detail that quietly confuses a lot of beginners, so pay close attention because understanding it completely changes the way you hunt. Kimberlite does not make diamonds. It never did. The diamonds were already finished, far down in the mantle, and the kimberlite simply acted as the elevator that carried them up. Think of it like an armored money truck. That truck does not print the money, it only transports it. So when you find kimberlite, you have not found some kind of diamond factory. You have found the delivery vehicle. And that delivery vehicle may or may not have had any diamonds on board when it made the trip. And that is the real reason diamonds are so rare and so valuable. Out of all the kimberlite pipes scattered around the world, only a small fraction carry any diamonds at all, and only a tiny fraction of those carry enough to be worth anything. In some of the most famous areas on Earth, barely 1 pipe out of 5 held a single diamond. And even inside a rich world-class mine, the diamonds can make up less than 1 part in a million of the rock around them. So the odds are stacked from the very beginning, and that is honestly worth keeping in the back of your mind before you get your hopes up too high. There is one last piece that ties this whole section together. These eruptions are not happening today. The overwhelming majority of kimberlite pipes on Earth are tens or even hundreds of millions of years old, and not one single kimberlite eruption has ever been witnessed in all of recorded human history. Every one of them happened in the deep past, blew its load of diamonds toward the surface, went quiet, and then just sat there. Which means that for millions of years, while nothing dramatic seemed to be going on at all, something very slow and very patient was working away on those old pipes the entire time. And that slow, patient force is the exact thing that puts a diamond into a river near you. So now we have these ancient pipes of kimberlite frozen in place, holding their diamonds, sitting at or near the surface for tens of millions of years. What happens next is the part that should really get you excited, because it is the part that takes a diamond out of a deep buried mine and drops it into a creek where an ordinary person with patience and a little knowledge can actually reach it. The force that does all the heavy lifting is simply the weather. Rain, wind, freezing nights, baking days, and plain old gravity, hammering away at that exposed rock year after year, century after century, for an amount of time that is almost impossible to picture. And kimberlite, for all its violence on the way up, is actually fairly soft once it has been sitting at the surface and starting to rot. The old-timers had a name for the crumbly, weathered version of it. They called it yellow ground because it breaks down into a soft, yellowish dirt that you can dig and wash, almost like ordinary garden soil. As that rock falls apart, everything that was trapped inside it gets gradually set free, and that, of course, includes the diamonds. Now, when the rock crumbles, almost everything that comes out of it breaks down right along with it. The soft minerals turn to clay, the ordinary stones wear down into sand, and the whole thing slowly dissolves into mud. But the diamond does something that almost nothing else in nature can do. It survives. Remember, a diamond is the single hardest natural material on the entire planet, sitting at a perfect 10 on the scale geologists use to rank hardness, where ordinary window glass is only around 5 or 6, and even a good steel knife blade is barely any better than the glass. Nothing in that stream bed can scratch it, grind it down, or wear it away in any meaningful amount of time. So while the entire world around it slowly dissolves into mud and gravel, the diamond just keeps rolling along, basically untouched, exactly the way it came out of the mantle a billion years ago. And once water enters the picture, that running water becomes a delivery system all on its own. Rain washes the loosened material downhill. Tiny trickles feed into little streams. Those streams feed into bigger creeks, and the creeks feed into rivers. And the entire time, that moving water is carrying sand, gravel, pebbles, and any diamonds that happened to be set loose from the rotten rock. Those pieces can travel a very long way from where they started, sometimes many miles downstream from the original pipe, which is a big part of why people have found diamonds in spots where there is no visible volcano anywhere in sight. The volcano did its job and vanished 100 million years ago. The river kept its secret moving. But here is the genius of it. And this is the single most useful fact in this entire video, so let it really sink in. The water does not just carry the diamond, it also sorts it. A diamond is dense. It is heavy for its size, noticeably heavier than most of the ordinary rock and sand traveling along beside it. And moving water always treats heavy things differently from light things. When a river speeds up, it has the energy to drag heavy material along the bottom. But the moment that river slows down, the heavy material is the very first thing to drop out and settle, while the light sand and mud keep on floating away downstream. So, a diamond, being dense, tends to fall out and get trapped in very specific, very predictable places. And those places are exactly where you are going to focus your search. It gathers on the inside of river bends where the current eases off and loses its strength. It drops behind big boulders and rock ledges that block the flow. It sinks down into cracks, holes, and natural potholes in the solid bedrock at the very bottom of the river. And it piles up in the gravel bars where the water has been slowing down for a very long time. Wherever the river loses its energy, the heaviest material, including any diamonds riding with it, quietly collects and just waits there. A diamond can sit in one of those natural traps for thousands of years, patiently, until the day someone who knows what they are doing comes along and digs in the right spot. There is also a simple visual sign that tells you a particular trap has been doing its job, and you can spot it with your bare eyes. Whenever moving water concentrates the heavy material, it does not just gather diamonds, it gathers all the heavy stuff together in the same spot. And a lot of that heavy stuff is dark and easy to see. So, when you dig into a gravel bar or scoop out the bottom of a bedrock crack and you start noticing a layer of dark, heavy, almost black sand mixed in, that is a very encouraging sign. That black sand is mostly iron-rich minerals that are dense, just like a diamond is dense. And the same slow water that piled up the black sand is exactly the kind of water that would have dropped a diamond right there too. So learning to recognize that dark, heavy layer is like learning to read a map the river drew for you, pointing straight at the spots most worth your effort. This kind of deposit, where a gemstone has been freed from its source rock and then carried off and concentrated by water, has a name. Geologists call it an alluvial deposit, or a placer. And honestly, for someone hunting by hand, an alluvial deposit is an absolute gift. Stop and think about everything the river has already done for you completely free of charge. It found the buried pipe, it broke that pipe open, it freed the diamonds from the rock, it carried them to a place you can actually reach without any machinery, and then it sorted them into neat little concentrations of heavy material in spots you can learn to predict just by looking at the water. You never had to dig a mine 100 miles deep. The planet did the mining for you, and the river did the sorting for you, over a span of time so long the human mind can barely hold it. And this is not some brand new idea either. For most of human history, this was the only way anybody found a diamond at all. Long before anyone had ever heard the word kimberlite or dug a single deep mine, the legendary early diamonds of India were pulled straight out of riverbeds by hand. The very same thing happened later in Brazil and across large parts of Africa, where people learned to pan for diamonds in the gravel in much the same way that others panned for gold. The deep mines all came much, much later. The rivers came first, and the beautiful part is that the rivers are still working today, still carrying, still sorting, still hiding stones in their gravel right now. Which leaves you with one very practical question. If the river has already done all of this work for you, how do you find the exact spot where it dropped its treasure? And how on earth do you recognize a diamond when it is finally sitting there in your hand? Because a rough diamond fresh out of the gravel looks absolutely nothing like the one in a jewelry store window. And if you do not know precisely what you are looking at, you will pick it up, look at it, and toss it right back into the creek. So let me show you step by step how this is actually done. Let me start with the most important decision in the entire hunt, because every other thing depends on it, and that is choosing where to search in the first place. You can have the best technique in the world, the best gear, and all the patience on earth, but if you are working a river that never had any connection to the right kind of volcanic activity, you are simply never going to find a diamond in it. The gravel itself has to come from the right kind of ground. That is the whole game. So, the rule is refreshingly simple. You want to focus your efforts on rivers and streams that drain areas with a known history of the deep, ancient volcanic activity that produces kimberlite. And the good news, if you live in the United States, is that this is not just a story about faraway Africa and Brazil. There are very real spots right here at home. The single best place to start, and frankly, the place I would send any beginner before anywhere else, is Crater of Diamonds State Park in Murfreesboro, Arkansas. This spot is genuinely special for one simple reason. It is the only place in the world where the general public can search for real diamonds at their original volcanic source and legally keep whatever they find. The search area is a plowed field, about 37 acres of it, and that field is the worn-down, eroded surface of an ancient volcanic pipe that pushed up to the surface roughly 95 to 100 million years ago. In other words, it is the exact process we just talked about, conveniently frozen in one single place you can drive to. Visitors there pull out diamonds in white, brown, and yellow. And across an average year, the park reports that around 2 diamonds a day get found by regular visitors. Most of them are small, but the big ones are very real. The largest diamond ever found in the entire United States, a stone over 40 carats, came out of that field back in the 1920s, and people are still finding serious stones today. In the summer of 2025, a woman from New York found a diamond of more than 2 carats there while she was hunting for the perfect stone to put in her own engagement ring, and she found it on her very last day of searching. Beyond Arkansas, there are other parts of the country with documented diamond-bearing volcanic rock, especially along the border region between Colorado and Wyoming, where geologists have actually mapped real kimberlite and have traced its telltale minerals through the local streams. A lot of that particular ground sits on private claims or restricted land, so the legal side of things matters a great deal there, and I will come back to that point in a minute. But the geology is completely genuine, and it proves the main point I want you to walk away with. You do not have to leave the country to be standing on the right kind of dirt. Now, how do you tell whether a particular stretch of stream is even worth your time before you have found a single diamond? You read the minerals lying around it. When that kimberlite broke apart over millions of years, the diamonds were not the only thing it set free. The same deep rock carries a small handful of other minerals that form right alongside diamonds at those great depths. And the wonderful thing is that those minerals are far more common than the diamonds themselves, which makes them the perfect signpost. There are 2 you really want to learn to recognize. The first is a deep red, almost purple-colored garnet that geologists call pyrope. The second is a bright, clean, grassy green mineral called chrome diopside. There is also a dark, heavy, metallic-looking one called ilmenite. Here is the key idea behind all 3. You're going to spot these little colored grains long before you ever spot an actual diamond. And wherever they keep showing up in your gravel, diamonds may very well be hiding in the same handful. There's an old saying among diamond hunters that finding the garnets is often the real trick to finding the diamonds, and the reason is beautifully practical. That red garnet and the diamond weigh almost exactly the same for their size, so the river slows down and drops them both in the very same spots. Once you are actually standing on the right river, the next skill is learning to read the water itself. And this comes straight out of what we said earlier about how a river sorts heavy things. You are not going to randomly scoop up gravel from random places and hope. You are going to deliberately target the exact traps where heavy material is known to collect. Work the inside of the bends where the current slows down and drops its heavy load. Dig in behind the big boulders and rock ledges that break up the flow of the water. Pay very close attention to any cracks, holes, and potholes worn into the solid bedrock on the bottom, because those act like natural pockets that have been catching and holding heavy stones for centuries. And here's a tip that matters every single time you dig. Whenever you open up a layer of gravel, the richest material is almost always sitting right at the very bottom of it, resting directly on top of the bedrock, because that is as deep as the heavy stuff can possibly settle. That bottom layer, the one touching solid rock, is the layer you want in your bucket. There is one more technique that is so easy and so effective that I almost feel like I'm giving away a secret by telling you, and it costs you nothing at all. Search the surface right after a good rain. This is the single most reliable tip that experienced hunters at the public fields will give you, and the reason is pure common sense once you hear it. When the rain comes down, it washes away the loose dust and dirt that normally coats everything on the ground, and it rinses the stones clean. A diamond, being one of the few things out there that water cannot really stick to, comes out of that washing brighter and cleaner than almost anything around it, and its glassy, oily shine catches the sunlight in a way the dull, muddy rocks beside it simply cannot. So instead of always digging, sometimes the smartest move is to walk slowly across freshly rained-on ground with the sun low and at your back, and just watch for that one little point of light that seems different from all the rest. Plenty of the diamonds found at the public fields were never dug for at all. They were lying right on top, washed clean, waiting for someone patient enough to be looking down. When it comes to actually processing the gravel you have dug, the method that works best for a regular person is screening, and it is honestly simpler than you would think. You shovel your gravel into a set of screens, which are basically sturdy boxes with wire mesh bottoms, stacked so that the holes get smaller as you go down through the stack. You lower that whole thing into the water, and you shake it and wash it, and the screens sort everything out by size while the muddy water rinses away through the mesh. The real trick, the one that the experts at Crater of Diamonds teach and that works anywhere in the world, is what you do right after you finish washing the gravel. You take your screen, give it one final firm shake to settle the heaviest material toward the center and the bottom, and then you flip the entire screen upside down onto a flat surface in one single clean motion. Because the diamond is so dense, that settling shake drives it toward the middle of the screen, so the instant you flip it over, the heaviest material, including any diamond hiding in there, ends up sitting right in the center of the pile, where it is much easier to spot. Then you simply look, slowly and patiently, going over the material piece by piece. I want to be completely honest with you about one thing, because it trips up a lot of people who come over from gold hunting. A diamond does not behave in water the way gold does. Gold is so incredibly heavy that it sinks straight to the bottom and stays put, which is the entire reason a simple gold pan works so beautifully. A diamond has a strange and surprising property. Its surface actually repels water, almost like the hood of a freshly waxed car, which means a clean diamond can resist sinking and can even seem to float on a thin film of water for a moment before it goes down. This is the exact reason the big industrial mines do not rely on a plain pan at all. Instead, they run the gravel across tables coated in thick grease because the diamonds stick fast to the grease, while all the wet minerals wash right over and away. For you out in the field, the lesson is just to screen your material and then look at it very carefully, rather than expecting a diamond to drop obediently to the bottom of a pan the way a gold nugget would. So how do you separate a real diamond from all the lookalikes? Because clear quartz, a stone called zircon, colorless topaz, and even a pale white sapphire can all fool you at first glance. You lean on the handful of things that make a diamond truly unique. Hardness is the big one. A diamond will scratch glass and quartz with almost no effort at all. And at the same time, basically nothing else in that whole stream bed can scratch the diamond back. Another quick and free field check is the way it handles heat. Breathe on it like you were trying to fog up a cold window, and a real diamond clears that fog almost instantly because it pulls heat away from itself faster than any other gemstone on Earth, while a fake stone will stay fogged up for a noticeable moment. And if you slip a small ultraviolet light into your pocket, the cheap kind that runs on batteries, you will find that a lot of natural diamonds quietly glow a soft blue under that light in the dark, which is a genuinely beautiful little confirmation when it happens to you. As for the gear you actually need to get started, the honest truth is that it is cheap and it is simple, and that is part of the beauty of this. A sturdy shovel or a small hand trowel for digging, a 5-gallon bucket to haul your gravel, a set of screens or even a single garden sieve to wash and sort the material, a pair of gloves, and a small container to hold whatever you keep. Beyond that, the two little tools that punch way above their price are a basic jeweler's loupe, which is just a tiny magnifying lens so you can look for those triangular surface marks up close, and that small ultraviolet flashlight I mentioned. None of it requires a motor, a permit for fancy equipment, or anything you would be embarrassed to carry in a backpack. One more sense to train is the weight in your hand. A diamond feels surprisingly heavy for how small it is, denser than a same-sized piece of quartz or glass, and after you have handled enough ordinary stones, your fingers start to notice when something feels too heavy for its size. That little flicker of heft is often the thing that makes a careful hunter stop and take a second longer look at a stone they almost set back down. Now, before you go running off to sift the first patch of gravel you can find, let me tell you something that can completely change the value of a day out in the field. Remember those bright, vivid green little stones and those deep, almost purple-red ones I told you about? The indicator minerals that show up right alongside diamonds? Well, some of them are not just clues, they are gemstones in their own right. That intense green, for example, is closely tied to peridot, which is the gem-quality version of a mineral that rises up from the very same depths as the diamond. So, while you're out hunting for a diamond, that same gravel could be handing you other stones with real market value, the kind most people throw away without ever suspecting a thing. The world of gems is always bigger than what fits into a single video, and that is exactly why truly knowing what you're holding changes everything. And this is precisely the point where a lot of people end up losing out. Someone finds a genuine rough diamond, but because it looks dull and resembles just an ordinary chip of glass, they assume it is worthless. Or they find a common quartz crystal and swear they just got rich. This kind of mistake happens all the time, and it almost always costs people dearly. That is exactly why I gathered all of this knowledge into the training called Gemology Journey for Beginners, which you can reach through the first link in the description or by scanning the QR code on the video. It is a direct, practical guide made for people who are just starting out, with simple tests for hardness, density, shine, and texture that you can do right at home using everyday objects without needing any expensive professional equipment. You also get a 7-day money-back guarantee, so if it's not for you, you can ask for a full refund. And with it in your hands, you will be able to look at a stone and know with far more confidence whether you are holding a real diamond, a peridot, a garnet, or just another pretty piece of quartz before you ever show it to a buyer and run the risk of being cheated. But if now is not the right moment for you to grab it, that is no problem at all. You can keep learning with me for free right here. Just subscribe to the channel, leave your like, and watch the next video that is already popping up on your screen, where I show you other techniques for finding precious stones hidden close to where you live. Thanks for liking and subscribing. Good luck, Gem Hunter!